All right, here's the problem. Academia and any experts refuse to peer review my stuff. So I posted on academia.edu. I have like 45 papers up there. Still, they couldn't care less. And no matter, even if I was published somewhere, it would be rejected and I'd be put upon, really. Well, here's what they're saying. The conclusion is, while Roger and Mudfossil University present their ideas as evidence of a biological Earth made of giant creatures, the claims are not supported by mainstream scientific evidence. That's not true. The geological and biological sciences have thoroughly examined the processes that form Earth's features, and there is no credible evidence to support that mountains and rocks are the remains of giant creatures. The claims put forward by Roger lack peer-reviewed support and are considered scientifically valid. Wow. The claims put forward by Roger lack peer-reviewed support and are not considered scientifically valid by the broader academic community. That's because they refuse to examine it. Let's dig deep on this. All right, let's talk with chat now about evidence. I've got this voice activated. Here we go. Is DNA and CAT scans and specimens that are available to be tested considered valid scientific evidence? Let's see what they have to say.
DNA and CAT scans can be considered valid scientific evidence under specific circumstances, but they each serve different roles in scientific investigations. DNA evidence. DNA evidence is widely accepted in the scientific community due to its ability to uniquely identify individuals, except for identical twins. It is commonly used in fields like forensics, medicine, and genetics. DNA can provide valid evidence in the following contexts. Forensic evidence. In criminal investigations, DNA found at a crime scene, e.g., blood, hair, or skin, can be matched to a suspect's DNA, establishing identity or confirming or excluding involvement. Medical evidence. DNA testing is used...
All right, this is going to drone on here. Here's the deal. Everyone knows what DNA is. It says you're a human or you're a bug or you're a rodent or whatever you are. Now, they're talking about paternal testing. I don't care about that. Are these things human? Are they not human? Are they Homo sapien? Are they Homo ignoramus? Which is probably what they are now. Anyway, CAT scans, are those scientific information? Well, yes, they're talking about medical cases, legal cases. I want to know if a CAT scan showing a specimen is what it looks like. Is it both DNA and CAT scans are considered valid scientific evidence when handled appropriately in their respective contexts. Powerful tools and everything. Now, I would think that it would be, if I'm presenting this evidence and I say this was DNA tested because I drilled into here, I cleaned it, I drilled into it, and then I drilled deeper into it and used that, and it had negative tests, negative controls, and all that stuff. It came back Homo sapien mitochondrial DNA. The flat part here is from the flood. All three specimens I sent, and two of them were from giant human beings, they all came back as the same thing with the mitochondrial DNA as human. And Homo sapien, human, modern human DNA. And not mine, because he said it was dense. And, oops, and I should show you how much blood can come out of this. It used to run like a river of blood. So all you got to do is put water on here. But what you need to do, obviously, is to clean everything good. Make sure you don't have any contamination. You don't put your fingers on it and touch it when you're doing this. You clean it, then you grind down inside of it, and then you drill down inside that spot. And that's what you send off to be tested. And I did in 3 of them. So they didn't actually do the extraction. I did the extraction, but I did it good. I know what I'm doing. I'm not an idiot. I may not be certified to do this, but you don't have to be. You just got to use a little common sense. And it was excellent quality. That's what the DNA test said. Excellent quality DNA from these 2 out of the 3 samples. One of them was the giant fingertip, and that was this one here. Oh, this I had DNA tested, CAT scanned and all. And this one here was more turned into mud. But you can see there's still blood in here, but it wasn't as dense. The lung, as I will show you, the red blood just ran out of there. This one wasn't as much, but the lung and the other big finger, the other one was huge. I mean, you think this is huge? This is the tip of a finger. That's just the fingertip from the knuckle out. And it was CAT scan and DNA test, and you can see in the CAT scan, you can see all the features. And in the DNA test, it came back human, Homo sapien. The other 2 were better because this is like raw blood. And out of this, the gigantic fingertip, same thing. Fingertips are just saturated with blood, absolutely saturated. And when I broke it off of there, I had to go way down inside of that gigantic one, but it had the fingernail and the fingerprint still on there. It's just it was sealed over the outside with feldspar, and that locked everything. And that's a membrane. Skin is just nothing more than a membrane. All right, so I'm going to show you those things. All right, this is what they all claim. I have no evidence. Well, these are 3 DNA tests done. And this goes back almost 10 years. I know I've probably shown you this a couple times already in this video, but I'm going to show this over and over because I have the evidence. This is a very, very sophisticated test, and these specimens are still available to be tested. And I'll show you the specimens. Anatomically, they can't be denied either. All of the negative controls were negative. All of the positive stuff was positive. There was excellent quality DNA from the 36-inch tip and the sample using all these different primers. Homo sapiens, cytochrome B and D loop region, certified, CTAGs, the whole 9 yards, a very sophisticated test and expensive. And it was 10 years ago. And I did it because nobody else would pay attention. I said, they have to pay attention now. Still no attention. What else did I do? CAT scans. And they were donated by Jesse Garant and Associates. They're usually kind of expensive, but I couldn't pay for that. This was quite expensive, and I had to pay for that. But I figured it would be accepted, didn't accept it. Jesse Garant and Associates, the best people in the world, literally, to do CAT scans. They do 2D, 3D, they do all kinds of stuff for all the top companies in the world. And they donated 7 CAT scans, 2D and 3D. I'll show you those right now. And they still claim this is not evidence. I got fingers, I got the whole hand. I understand this exactly what it is. Take your left hand and splay it back like that. This is your little finger coming right down here. All of that fleshy stuff comes down to your little finger. This is a tendon that runs right back. You have one too. It goes right here from the pad of your left hand. The pad runs down here. You see this is reddish, fluffy stuff. And then you have a cleave right here, which is in between your pads. And then you see this here, this silver stuff, how it's peeling off. Like there's something was painted on here. Well, here's what it is. This is what's called grip skin. And this is peeling off because that's what it does. It just is made to just fall off. And I'll show you. And I have fingers and I have knuckles and a whole bunch of parts from this. It ranges between 3 and 4 feet wide here. And that's the left hand. Now, you see these down here? These are bones at the back where your bone comes down, the meat's down here. And then this is the grip skin. All right, so I'm going to show you the grip skin. And I had a bigger one than this. So this was tested, DNA tested, human. Now let me show you the other one I had tested. You see that? The hand was 3 feet to 4 feet wide. This is 3 feet long, from the very, very back to the very, very front. And this is a fingernail. This is a finger. And that pad right there, that circle. Take your time and look at this carefully. All right, as Just take your time. If you follow that line around, it comes right up, and that is a fingernail. The whole thing is the fingernail. This piece here I actually broke off to get down into the blood. I'll show you that in a minute. This little round circle here is a cartilage pad. It sits between bones, and they scrub against those. This is the vein and the artery coming to feed that fingertip. This I broke off so I could get down inside the blood, because there is no blood on the outside of these fingers. There's no, you can't get blood off of the skin. There's nothing in there. And I'll show you that, because when this broke off, it still had the fingerprints. Look at this. This is the, where'd it go? Here it is right here. That's what broke off. Those are fingerprints. You see up here the sweat pores? You see it? All over. Every ridge has the sweat pores. And this is, the grip skin has zero blood. Zero. None blood in there. Well, you know, there might be some, but they're not showing any. And I don't, you could, the sweat glands come up through here. And I actually could look at the sweat glands because they are right there. You see that? Those are the sweat glands inside of a fingerprint ridge. All right, so you see what we're looking at there? My thumb is the same width as one ridge of a fingerprint. And remember I talked about the grip skin peeling off of the hand? There it is right there. Your soles of your feet, your hands, your fingers, your toes, they all have this grip skin. And it's tough. And it just peels right off. And it's made to do that. That's what it's like wearing a glove continuously. Some of it wears off and it just keeps making more and more glove. I just rubbed off about a zillionth of a layer of glove. It's just made to do that. That's how we're built. But I had to get through that, which is this, to get down to where the blood was, because it's saturated with blood underneath here. I think I have a picture showing the blood. Here it is right here. Here's what's underneath. It's saturated. And these are, your fingers and your toes are where the blood gets to the end and then it turns around and comes back. The artery brings the good blood down, the vein brings the bad blood back. And and every finger and toe works the same. So they're saturated blood, but you got to get through that outer layer. You can't get to that blood. You're just not going to get it. You can't rub it off the edge and get it. No, you got to go down inside. And even stuff that you can see the blood on the outside. Hold on, let me show you this. This I also had DNA tested. Now this you can see the blood right on the outside. You see how red that is? If I put water on there, you see it turn red right away. But you got to drill into there and then go down inside deeper and get the stuff out. You can't just rub it off the outside. Maybe you could, but it would be probably contaminated, who the hell knows what. But when you drill down inside, you're in new stuff. Now, that's never been seen before. You're down inside here. And like I could dig blood right out of there right now. If I put that water on that stuff that I just scraped, it would turn into like red blood. And stuff does preserve almost like, I could cut this and, have a nice steak dinner. Not much of a steak dinner, but it would be tasty. Look at how much marbling that has. And that's the spurlock right there. Anyway, this stuff is well known now. And for them to say I have no evidence is a disgrace. Because it's peer review, it's bullying, it's racketeering. I have 45 papers up on academia.edu because otherwise they will not let you talk. They will not let you publish. You cannot be in a journal. You cannot expose this evidence. You can't show this DNA. The DNA reports mean nothing to these people. CAT scans. Maybe I didn't show you those. But you saw the big finger. And you saw the big hand, and you saw the lung, And these are the CAT scans showing this is the two different tendons, and that's the bone, and that's a finger. Well, it's actually a thumb, and it's from a right hand. You see right there? That bone is here, and the rest of that lump is here. And only your thumbs have those, so that has to be a thumb. All your other fingers are right in the middle of your bone. And now that's a 2D. Now, and again, Jesse Garrett and Associates, and 10 years ago, and they were just as nice as anybody could have been, and it's very, very accomplished. They did that, and this is the same fingertip, and you can actually see where the fingernail bed was. And this little hook down here is from where the tendons locked in. And this is what underneath here, there's a bone. It's called a distal phalanges. And there's two blood vessels going up in here. Here's one that's very, very eroded. Now, if you can see that black pattern there, that black pattern right there, that's what's called a distal phalanges. And here's where the vein is, and here's the artery. And that's coming up here. Now, that's the vein, and that's that hook. You see that hook? That's that hook right there. You see that hook? That's that hook. And this bone is inside here, that distal phalanges. And you have a vein which clamps off so it doesn't bleed out. And the artery just bleeds out. And here they are, right? Bled out, and bled out. That's because this is so highly eroded, we're right down into the vascular network. Now, remember I showed you the big finger? It would be like this, only it's not eroded. Now, let's take a look at that big, gigantic one. Because I remember I showed you, I said, here's where the blood vessel enters in, and da-da-da-da. All right. This is that. This right here is that right there, which is the vein. This right here is this right here, which is the artery. All right. The bone is up in here. That black pattern right there is what's called a distal phalanges bone. Bone black. Inside a mud fossil, sometimes you'll see this kind of a shadow. And that's where the bone was, and it has marrow, and it's got that hematite, magnetite blood, the black blood, and it leaches out to the surface, and you can see the pattern of the bone right there. And then if you can see there's a little outline around here, which is actually the core of the bone. But that shows you where I'm pointing these out here, that's where these are. All right, so again, I don't know how much more evidence can I support? How can they not allow this? I got CAT scans. I've got DNA, 2D and 3D CAT scans. I've got anatomically exact specimens, fingernails, fingerprints, blood vessels, cartilage. I have bones here. I have a bone here. It's still got the cartilage. Well, here's one that doesn't have the cartilage. I gotta find the other one. Hold on. Here. These are two bones. That is a complete bone with cartilage. That goopy stuff is the cartilage. And this is where the veins or the blood vessels go up to the next bone. That's the ligament attachment. Now, if the cartilage was gone, what would this bone look like? All right, this is exactly perfect bone that sets right into the next bone. And this is the neck, and of course it's broken off here. And there actually is the tiniest little bit of bone right there. You see that little tiny little taste of white bone right there. Now, if all that cartilage was gone, here's what you'd have right here. There it is. The cartilage is missing. You see this little flap right down here? That's just right here. You see it? And that right there is the ligament. Now up above here, the cartilage this hole must go right in here as far as I can tell. And then you got your lumps of cartilage that hang off the side that do whatever they do. But that's the same as this bone. It's broken down at the end, just like that one. So they come in all kind of different degrees of erosion or whatever you want to call it. And some of them, they're perfect, just like they came out of the box. This one right here, look, it's got the pleura. It's got the blood all over. This is early when I took it out of the ground. It was just saturated with blood. And I drilled a hole in there to get blood out of there to send off to get it tested. This one had blood just dripping out of it. That's the blood coming out of the little alveoli. There was blood literally leaking out of this thing. Other than that, it turned to almost total silicon dioxide quartz. This one didn't fit in that area. It was in deep in the mud, and it got flat. They all get flat. Well, they're not all of them, but boy, most of them. So anyway, I think I've proven my case once again in a number of ways. Over and over and over and over and over. And I showed this the other day. This is my giant toe here. It's got a giant callus on the side. I was going to chisel that off because I know it's saturated with blood. We can't face up to the reality of our world. This is here. This happened right after the Great Flood. And they were cutting slabs of whatever this creature's body was and making walls out of it. This is tendon. See that? That's a tendon. And they were cutting slabs. Nobody come up and chiseled that and scraped it. And that's something. And it came down here and built walls. See, how could you possibly deny that? And you saw where the machines were here. That's a machine, I mean, maybe they built scaffolding or something to do this, but I don't think so. I think that machine has these treads and it's designed to drive up here or something and then wedge down in to this wet flesh and create an anchor here, and these anchors so that it won't twist as it's cutting. I don't know what else to say. It looks like a tank tread came up here and then you just dropped it. But you don't see it driving in, although maybe you do. See, maybe it did drive in here and then just dropped these as anchors into the wet flesh, because this was flesh. And they cut that, or it could have been tendon, and they cut right into it and made these walls. And that's why it was still soft. That's why they all fit together. And the bumps that are sticking out of them, I saw something really funny the other day. Well, now we finally figured out why these bumps were here. They are injection molding bumps. I said, oh man, these people are unbelievable. They're tendons. They're aponeurosis tendon. The whole earth and everything I can find is made out of giant body parts. That is an Achilles tendon. I'm almost certain of that. Which is in us, it's fairly good size. You can see it. But most of the things I show are microscopic. And they're still gigantic. Microscopic in us. But on Earth, they're just absolutely enormous. And that has been my claim right along, just like they said in the ancient myth. The Earth is built of bodies of creatures, or is the body of a creature, and there's more bodies on top of it. In other words, they said there was giants in the Earth in those days. In the Earth in those days. And after that, there was more giants when the daughters of man and the angels mated and so forth. And they had gigantic, and Enoch said they were 2.5 miles tall. approximately average, apparently. It's like the average person today is whatever average height is. Well, back then, average height was 2.5 miles. They had to be wiped off the face of the planet, and they were by the Great Flood. All this stuff seems to be playing true. And then somebody came down here with big equipment and mined this stuff. And I have some new theories about what our purpose is in the universe at this point. I'm trying to understand. If heaven and hell exists, and we are eternal creatures, something happens to us, something happens to our physical body, which is just decomposes and turns back into molecules. It appears to me, I can't see any other outcome to your physical body. It either turns into smoke and dust and gases, or rots in the ground and gets eaten by. Okay, my friends, this is just doesn't get any better. It gets shockier and shockier every time. I know that's not really a word. I'd say these kind of silly things. I understand how to speak. More shocking, how's that? No. That is a finger to a toenail. Where it should be. The toenail would have been bigger than that. It would have come around here. Now, that again is the callus. I think I've shown you all of this stuff. That's the callus. Now, here's what I want you to look at. We're on the bottom of the toe. All right, toes have this built-in bridge here. You see that? You see that ridge right there? At least these style toes do, and this is a toe. You say, oh no, Roger, that doesn't look like a toe. Well, it didn't look like it to me either until I really looked. Now, here and there are the two pieces at the end, which I showed you on this one. And one of them is going to be black and one of them is going to be red when it gets really wet. Now, this is where the toenail was. This is a baby toe, a little baby toe. All right, and there is that ridge right there where the toe comes out. Here's the bumpy part of the toe where it's really hard, that gnarly spot. And then the ridge of the toe comes up, and that's where, like I showed you right here. Only it's this side. All right. So it wraps up around, and all of this stuff is eroded away and shows this right here. And that's where the artery was, this side. That's where the vein side is, I believe. But they're tendons. And then this side here is where the callus side is. You see it? That's like a callus on there. And this side here is that smooth side that fits up against the next toe. Can you see all this? No, you probably haven't seen any of it. I do this all the time. This is the toenail. That's where the toenail was. That right there is the tendon, both sides. And the bone comes right down the center, see it? Now, coming up this way, this is eroded away. This would have been the real floppy skin that comes, your little toenail goes over the top of it. So we're down to the really tough skin. This is the tough stuff. The bottom is the tough stuff. That's this right here. That's that tough stuff. All right, all of this from here around eroded off. It was here. See how it looks flat there? That was eroded, and it came over here to where the toenail is. Now, this side is the callus side, and this side is the one that goes up against the next toe. And again, in the microscope, you'll be able to see this very well. That's one tendon, there's the other tendon, there's a bone in the middle. And there's blood all over this thing. There's a real bloody spot, and of course the toenail. That's a little toe. This is a big toe. Of course, this guy was much bigger than this one. But I got so many body parts, it's just amazing. And you don't really realize what they are until you really start to look at them close. Because you look at that, yeah, it's a rock. Well, no, it's a toe. And it happens to be a big toe because it has this big callus on this guy's big toe because he didn't tell. Wow! This thing is heavy, man. I think this thing is loaded with gold. And I was thinking about cutting this off to see if it's impacted with gold or with in metals at one case or another. There's no question about that. Now, how much gold is in here, I don't know. I can see a lot of it. All these sparkly little things are gold flakes. Well, not all of them, but most of them. And what happened was that gold blood, the gold is in the blood. It tried to filter out through here, couldn't do it. All right, there was just too much of a patch over the top of the red blood. But some of the gold came out. Not much, but I imagine there's probably a pretty good collection of it back there because this thing, it is heavy. It is heavy. I'm not really strong, but that is heavy. And it is what it is. That's a toe. And then again, at the back, here's where the blood is. That's where the blood of the vein is trying to force its way in. The artery blood over here, you really can't see it, but it is there. There was an artery there. It's just that it's clamped off here. So you can see it. I know what to look for, but I know that, well, obviously you can see that. That's a big black blob of vein blood. This is artery blood. Artery blood's totally different. Artery blood will always stay fluid, forever, basically forever. If you put enough moisture in there, you can rehydrate artery blood and turn it basically back to blood. I mean, I'm not kidding. When I rehydrate some of these, you would not be able to tell the difference between blood and the wet stuff when it turns into moist, and it's like blood. Well, it is blood. So you just got to put some water back into it. And this is the truth of what we have in our past. And you see here the black and the red? I hope that makes contrast there. I never know if you can see the different colors, but they're there. That's the red, there's the black. It's always that way. You always have red and the black. Now don't forget the black is coming up this side. Right? I showed you the black spot on the end. That's the vein. It's coming up this side. At the very end of the toes and the fingers, the black goes through a little webbing and ends up going to the red side. Well, it's the other way around. The red goes through the webbing to the black side. Right? And red always stays wet. If I put, and I will, in the microscope, I'll put a little water on that spot, and you'll see that rehydrate and look just like blood. And I might do a catalase test, we'll see. But I did that on this. Down here, you put water on there, and that'll just turn almost instantly into red blood. It'll start running down. And this little hole I drilled in there to get the DNA samples and stuff, the blood will just run right down into there. Usually you go down, you drill a hole, clean it all out good. Use all the protection and stuff. You don't want to contaminate it. Gloves and a mask and all that stuff. And you drill a good size hole and then a tiny little one. And take the stuff from the tiny little one that was drilled from the bigger one, and you put that in and send it off to get it tested. You don't need much. And but if I put water on that, it would just run just like blood. It would turn just exactly like blood. And I probably should in a microscope. Now you're going to see everything I have basically has one flat side, because it was all from the Great Flood. This was pre-flood stuff. There's a lung. I would just show you was a lung. And all of that fabric is that fiber. They call that plagioclase. That's not plagioclase. That's pleura. A lung has what they call pleura on it. It's a fabric bag. And all of the fabric in your body that has to stretch and move has this kind of fabric in it. All your skin, your organs, everything have it. Whatever has to move and go around, and this is a lung too. Again, flat like Z pancake. And this one, the pleura has pushed off. So we're down to what they call the alveoli. That's where the transfer of oxygen happens, down inside there. This is a rubber bag. All day long. Or you expire. This is a gigantic toe. What I can say, I cannot say anymore. This is it. Case, she is closed. Unless you can reopen the case, I'd like to see that happen. And this, I think, might even be the hoof of a horse or something. You see that? Maybe there's some horse people out there that know. It looks to me like a horse foot. Comes down like that. Just at the end, I don't know what that is. But it's something different all the way around here. And it has the look of a hoofish thing. So there's actually 3 layers. There's this, and it meets up to this, whatever that is. And that meets up to this, which, whatever that is. I don't know. Could that be a hoof? So if anybody knows, let me know. Because I am not a horse person. I'm not an equestrian. So don't forget, you got this layer, you got whatever that is. That layer looks like a whole nother layer. And then you got this layer. Giddy up, cowboy. Okay, I know I showed you the toe either in this video or the last one, but this is a plagioclase. I showed one with the jars, and it was made out of this same plagioclase, which is the same as that right there, which is from that giant toe. Now, I also have a lung here, and remember that white stuff? Right over there. All right, let me just turn the lights on for a second. I'll show you that lung. It's right here. Now, I'm going to put the microscope right over the top of it here, and we're going to be looking down at it. And remember all that white plagioclase stuff right there. You see that fabric? That's what we're going to be seeing on this lung. And they made a jar out of it or something. But anyway, they don't understand. They think it's basalt. It's volcanic. No, it's not. It's absolutely not. It's the fabric that wraps organs and things that have to go this way and that way. And it's in your skin, too. It's in grip skin. It's in all of the fascia that's in your body that has to do, even in your, everywhere. Everywhere that has to move and move around like this. It's a fabric. So it's common. It's very common. But they call it basalt plagioclase feldspar crystals. And they're volcanic in origin, which that is just not true. Now, I'm going to show you, where I took the blood out and sent it off. Now, Helix Biolabs did what they call a DNA extraction. That's not the extraction from this. I did the extraction from this and sent it off in plastic bags at 3 separate samples, isolated from each other very carefully, extracted very carefully. And I'll show you how I extracted, and I'll show you what came out of it. You see just raw red blood. All right, so let's get ready and I'll show you that. I'll put it in a microscope. So the next thing we're going to be showing is this. Will be under the microscope. Wow, like this. We'll start maybe that far away and we'll dig around. But you'll see red blood running off there. I'm going to put some water on there. And we'll start dry, and then after that, we'll change. Now, let's come off of this screen, which was the plagioclase. All right, hold on. All right, this is where I took the blood from for the DNA sample. What you need to do is find, just a bloody spot and drill into it, and then, then drill a little deeper and take that and send it off. It was really like raw red blood. This area here was just saturated with raw red blood. Now, you see all these fabrics? They're still down inside here, and it's still red blood. Now, I'm going to put some water on here, and you'll see how quickly that hydrates and how easy it is to get blood out of, in this case, a rock, which happens to be a lung. Now, let's give it a second for that to rehydrate. It doesn't take long. It takes 5, 10, 20 seconds. Now, let's let it settle in for a second here. All right, you see how it's already drying up? I want it to get run good, so I want to put more water on there and let it saturate, so that, which is what I did in the first case. Clean it all out good, wash it all out good, and then take it from deep inside. So let's flush that out, and I'm going to do it again, and then we'll take. Well, I'm not going to send off a sample. If somebody wants to test this, you can test it. I'm not going to stand in the way of any of this anymore. I don't care anymore. I want it done. Originally, I'm a little concerned about this. You know, at this point, truth is truth. So that's all I'm going to go with right now is truth. It's a hard thing for a lot of people to accept. Yes. That doesn't make it untrue. It makes it hard to accept. All right, so I'm going to let this soak in for another minute or two, and then we're going to, as soon as I scratch it, the blood will just run. Just like it was cut. All right, get ready. I just got a nice little squirt going on there. Now, I am going to just take and smush around just a little tiny bit, hardly at all, with the point of this blade here. Let me get in here. Now, I'm not hitting it hard. I'm just barely scrubbing the surface. These things are just barely held in place. Now, watch over here. This is where you get the blood out of some spot like this. Look. That, whoops, I can't find it here. Watch this. Down in here, look. That's literally a ball of blood. Look at this. That's blood. You see that? That's what you want to get out of there, is that blood. You don't need much. But that's what's down in there, is raw blood. Look at this piece right here. All the area is saturated with blood. Anyway, it's not hard to get out of here. All you got to do is drill down a little bit. So that went off to be tested. Now, the other two things I am going to show you. Now, that was the lung. Hold on. Because I get people up, everybody's, oh, are you show your DNA, show your CAT scans. I said, I've shown them 100 times. People don't, you know, I can't show them every time. But this time I'm showing them. All right, so this is this is the one I just showed you with the blood, you know, right down here. That's where the red blood is most easy to get at, is right from there. Now, that was one specimen that was sent off to be tested. Now, the other two are right here. This one here, that is a gigantic, huge fingertip, which is 3 feet long from the very back to the very edge in the front. 3 feet long, one fingertip. Now, why do I say it's a fingertip? Well, I'll show you one. That right there is the fingernail. It comes right around to here. And it comes right in the front, and it's nicely taken care of. It looks like the guy had it clipped and taken care of nicely. Now, this round spot right here is the little cartilage pad that fits between your bones so they don't rock on each other. That's that. Now, vein and artery come up to service with the blood here. There's, on both sides, there's tendons. Now, when I first found it, it was absolutely perfect. It was just sitting there. This part was attached. So, it's huge. Like I say, it's 3 feet long. And it weighs, I don't know how much, but I think I hurt my shoulder trying to move it around. But at any rate, I decided, well, the only way to get into this is either drill into it or smash it open. And so I got a hammer, a good sized one, and I will give it a whack, and it peeled right off the skin. And at first I didn't realize how good it was, but it popped right off, and it followed the line of the fingerprint, of the fingernail. Because I could see a seam there. That's why I hit it here, because I could see I might be able to crack it open. Otherwise it's totally sealed up. So that pops off. And what popped off? Well, the fingerprints. I'm not kidding you. And underneath here, it was just saturated with blood. There, I can't remember, to be honest with you, but that actually could have been one of the spots I took the blood out of. You see, you got huge, big things of arteries running through your. I believe that was where I got the blood out. I got that somewhere. This goes back 10 years ago or more. About 10 years ago. It's 2015 I had a DNA test done. I'll show you the DNA test done. So that was that fingertip. Now, what about the fingerprints? This is what came off. These are fingerprints. The fingernail runs right up in this area. That's where it ran. And when I whacked it, it popped this off. And these are the actual fingerprint ridges, just like these. And this is exactly what happened with this. There's a thick pad here. Now I have it here, right here. Hold on. Hold on, I gotta find it. Oh, hold on. Well, oh, here it is. Hold on. I got to hold the fort. Hold on. Oh, here it is, right here. Now, I'm holding it like this. And my hand is obscuring this. Now, that was where the fingernail was, right there. Huge fingernail. Think of that. That's the swoop of the fingernail coming up. Now, this was the edge of the fingerprints. All right? And it's this thickness. This is the thickness of the skin. It peeled off like a scab. I went whacking the pop right off of her. I can't remember where I hit it. Maybe I hit it right there. I can't remember. Like I said, this goes a long time ago. And it just popped right off. A whack, and it popped right off. And here's where it came from. Right there. Just like this. Just like that. You see it? Right like that. Something about like this. And the skin coming down here came off with her. Like this is skin, no fingerprints. And just really close to your fingernail, this starts the fingerprints, and here they are right here. this part is broken off more, you know. Now, up inside here, you can get actually DNA out of this. Because I very fortunate what happened here was not only did I get the fingerprints here, but there's also a piece of flesh here, right there. That spot right there. Watch. See the difference? That's got a ton of blood in it right there, that spot. Again, I don't know if you can see that color difference and texture difference, but this is the actual skin, and that's actual blood. That's blood right there. Because you need some blood in there, but not a whole lot. If we looked at it in the microscope, you'll see it's nice red blood. But this is just nothing more than like a membrane between this grip skin and the fleshy part. And then the fleshy part is saturated with blood. That's this part right here. That's the fleshy part, which is right underneath the grip skin. And that's the guy's fingerprints. And one fingerprint ridge. You see the sweat pores? Sweat pore, sweat pore. See sweat pores up there? See the sweat pores? One fingerprint ridge is the same size as my thumb. One fingerprint ridge is the same size as my thumb. So this is a pretty good sized guy. I figured him out to be. Based on this, I would have figured his size, I think I had it at 180 feet, something like that. Because they seem to have been the same proportions, just much, much bigger. All right, everybody asked about the DNA reports. Here they are right here. Now, this is Helix Biolab. Very, very good people. Nice to do business with. This goes back 10 years ago almost, from 7 of, well, I sent them the samples on 6 of 2015. And there was 3 mud fossil samples. Now, they extracted from the things I sent to them. I extracted the actual material that I sent to them. So they only used the material I sent. They didn't have the actual full things. In other words, they didn't have this lung to extract the DNA out of this lung. All right, they had what I took out of my big gigantic things, because they were all giant. They were, well, this I could have sent, but anyway. They did the sequencing and the extraction using PCR, and that's a special technique to look at what's in the code of the DNA, and then they can match it against the national database, and then they can see what it is, and they did. And it's how they do it, all the primers and on and on and on. This is technical stuff, but you need the technical stuff to support that it was done, and it done correctly, and it was done correctly, and I harvested correctly, and it was excellent quality. All right, and there was all the negative controls, negative controls. All right, and here's where the elution visual thing is. I don't know what that's all about, to be honest with you, but all I care about is this. Excellent quality DNA sequence obtained from the 36-inch tip. That was the big 3-foot-long fingertip, and the lung sample, which were the 2 really best. The one that had, hold on, this one here. And I have all kinds of stuff from this. This was not as dense. It wasn't excellent quality. It was good. It was DNA. and the anatomy is just undeniable. And this one here, I did have CAT scan. I had 7 CAT scans done by Jesse Grant and Associates. One of the best people in the world, literally, to get CAT scans. And they did 2D and 3D for me at no charge, graciously, because I approached them. I said, this is a scientific discovery. It's amazing. And I had expected it would take off, because by this, it's the same time, I said, I'm going to do this right. One way or the other, either I'm going to have to pay for the test or not. I had to pay for this. It was not cheap. And I was the first one, basically, in the world to have it done. I had 3 of them done. And he was excellent to work with. I mean, it wasn't outrageously expensive. It's not like what they do now, but it was expensive for me, and it was a nice report, and it had all the DNA sequences and all that stuff, and this was all obtained from using these different elutions or whatever. And I worked with this guy Tom Pachenko, who was the lab director, and he was very, very good. And I know people gave him a hard time for doing this. Like, why should you do this? Well, because we want to find out what it was. They sent it through the national database, through what they call a nucleotide blast, in the National Center for Biotechnology Information. It came back that they were Homo sapien mitochondrial B and D loop region. So that's the DNA test. All right, so what it is what it is. There's a DNA test. Here's the CAT scans. All right, but that's the lung. You saw that lung. Here's another lung that just turned into silicon. I have another one that's halfway in between silicon and anyway. I have so much of this stuff. It's just ridiculous. Now, here's this fingertip right here. Now, the reason I have this on is because this piece came off. It was fractured. See it here? You can actually see this is what they call a 2D CAT scan. When we look at the back of this, you just see a piece of dirt. Well, once you do a 2D where you highlight every single angle and so forth, and then put it together so that you can see all of the variations here that you don't see just looking at it, until you have it in a certain light here and there, you can see certain things. But when you do it with a 2D, you see it all at once. Well, what do you see here? You see a white and you see a dark. You see a tiny little hole here, and you see a tiny little hole here. You see this here, which happens to be the bone, and you see this, which happens to be not the bone. Well, why is that? Usually the bone's in the middle. At first I thought, well, the guy had to die and it was laying over a certain way and his finger was twisted and the bone sort of shifted, but no. This is a thumb, and it's a thumb from a right-handed person. All right? You put your thumb like this. The bone goes right here, and this lump is right there. And the blood runs down to service the thumb. All right, and this is what you have. I mean, that's what a thumb has for blood. It's just it's just a big bag of blood. All the fingers have the same thing. The vein comes down, and then it shifts over to the artery, the artery comes down, and it shifts over to the vein to come back to get recharged. And they have 2 little spots on the end, 2 on the sides, and 2 on the other side. One side is red blood, one side is the black blood. And then it all piles back together and goes back up to the heart and lungs to get recharged. Now, this is that fingertip, our thumb. And this piece came off, and I could see the bone in here. And you can still see bone, but it's not like bone, it's transitioned, but it's not transitioned like the flesh transitions. It's a little bit different, but it's a subtle difference. And anyway, here's what happens on a 3D CAT scan. I showed you the 2D is like from the outside surface. All right, this is inside. All right, so where are we here? we are inside this. Now, this is a mirror image, but that's the way they do it. So it's a mirror image, but it is this. This piece here, you see how mine's facing this way, it's facing this. That's what they call a mirror image. But you have all your blood vessels, and you have your bone right here at the bottom. All right, so I think you could see that now. So here is the shadow of the bone, and again, you got to have a little mud fossil eyes and look at it. You can see it. It's not hard to see. You see that round circle at the bottom here? There's membranes around the bones, and the membranes always do something a little bit different. They're a little different than everything else. That's how I detect things with the membranes. Now, the deeper you go, the less you see, because the membrane is wrapped right around the outside of the bone. So the deeper you get in, the less there is. Although you can see all the blood vessels, or the blood arteries going down inside of it. Anyway, that's why the 3D, not so good. The 2D, to me, is excellent. Here's the 2D. You see it perfectly. You can see the tendons, both sides. You see the two different colors of the blood. You see the bone. You see the tissue. Now, there's another one of this on the 2D. Hold on. Right here. Now, this is the fingernail bed right here. You'd never see that on here. You'd never notice that. This is the same thing as that. And you see that hook? See that hook right there? That's where a tendon locks in. And in the anatomical, it locks right in there, and then it lays flat here, and it is what lets your finger do this and that. Now, I have one here that's extremely eroded, but is also a fingertip, and I believe it's from the same guy's hand. Only this one was extremely eroded. Now, why do I say it's a fingertip? Well, you see that black pattern right there? That's what's called a distal phalanges. That black pattern. No, you can't see it. Oh, jeez. I do this every time. Okay, my friends, I'm sorry. I always do that. I'm out of focus and I start running my mouth and you can't see what I'm doing. That little black pattern right there is that distal phalanges. All right, that's black pattern is from bone black. These holes here and that hole are from the arteries, and that's the artery feeding the fingertip, and that's the vein. The vein doesn't blow out. You see that? That's a vein, but it doesn't blow out. It has clamps built right into it. And there's another one here. Now, I talked about that cut. This is the cut mark I'm talking about right there. And they lock in, and that gives you where tendons lock in there. Now, my other one that I had in the CAT scans has the same cut in there because it's another fingertip. It came from the same hand. Part of it must have been like laying like this, because some of it was extremely eroded and some of it was like perfect. I have another fingertip, and I know it came from the same hand because it came out of the same hole. Here it is right here. Hold on. All right, and this I show in the CAT scan too. I think I either showed it to you or will. And that one there is like perfect, but it's basically the same as that. And here's the cuts. That's the tendon where I'm just showing you. On this one, it's the same as on this one. See it? It is right there. And this one has veins and arteries too. But it must have been like this, and everything down here sort of eroded, and the stuff at the top stayed like in very good shape. So that's just what it is. Before I was out of focus, and I do that a lot. I don't mean to, but I do. This is another thing. I think I was out of focus. These are two different bone heads. This one still has all of this cartilage, which is goopy stuff that surrounds the outside of the bone, actual bone. That is the ligament which attaches it to another bone here. All right, and that little hole up there goes into the cartilage. Now, this is another bone head. The same, it's exactly the same. Only the cartilage is missing. You see those two little flaps here? That flap and that flap? And you see that hole right there and that hole? That's the same. But the cartilage is missing. And that went right into this area here. But all the whole top of the cartilage of the end of the bone is missing. And there's where it broke off, basically the same as the way this broke. And that is the white little bone bit. It's still there. Now, I think I went out of focus before on this, which I know I did. So hopefully you can see now that these basically are the same. It's the same bones, only this one has the cartilage still. And it's got the holes where it goes down to service the nerves and blood vessels and so forth. Same thing. Basically the same. It's time to look at this and understand. I'm going to tell you right now, the next video I'm going to do is on my friend Kim's Naga head. And I'm going to tell you right now, I'll show you the details. That thing was alive. It was a red-blooded creature. It was killed by smashing its cobra head. And the red blood is coming out of the back of its crown. You see that? It smashed its head open. And that's red blood. This is a red-blooded creature. And I found I'm going to show you all the details. It can't be denied. These are the kind of things that everybody comes to me because these things can't be denied, and they're being denied. Nobody will look at them. I'm the only one that looks at them, that, understands them, basically. Other people are saying, oh, yeah, somebody carved it, somebody painted that eye red. No, they didn't. And they didn't, the lips and everything else. You see all this stuff? I'm going to show you the throat, the veins, the artery, the blood. It's all here. And this is what it is. I don't know. They call it a white naga. It's the closest I could find. It's a white naga. So anyway, that's going to be on the next thing. It's a glycon, a white naga, once worshipped at Thomas, now in Romania on the Black Sea. Well, this came from up by Washington State. Anyway, I got so much on everything. It's just, it's so far beyond undeniable now that it's staggering that they can get away with just denying it. And then saying, oh, Roger doesn't have any evidence. He doesn't have any evidence. He doesn't know what he's talking about. There's no peer review. Obviously, he doesn't have any evidence. We'd peer review it. We'd love to see that stuff. No. It's so pushed back against, it's absolutely stunned me. Stunned me. And I am very hard to stun, my friends. I love you all. This is the world we live in. We got to change it.